All right, so now you should be looking at this screen. Okay, so it says if g is the inverse function of f, then f of g of x equals x, and g of f of x equals x. So if I have two equations, whatever like f of x is, whatever g of x is, one way to confirm that they are inverses of each other is to find f of g of x. My answer there should be just x. And then find g of f of x. And the answer there should just be x. So some of the questions in this section are just going to say, verify that f of x is the inverse of g of x or vice versa, and that's what it means. Take one, plug it into the first one, simplify it. You should get just x as your answer, and then reverse it. Take the first one, plug it in the second one, simplify it, and it should just get x as your answer. The little f negative 1, so when it's written like this, denotes that that is the inverse of f of x. So if I ask you, which I will, to find the inverse of f of x, you'll write that as f negative 1 of x. That's how you know I'm talking about the inverse of the other.
So that's how we like put the answer in?
Yeah, and you'll see when you get to, it'll say like find the, so there's different kinds of questions in here. First is verify, then is find it. And when you find the inverse, you'll do f negative 1 of x. Sophia, okay. Still? No. This one's going to say use the inverse function property to show that f and g are inverses of the other. So if it says to show it, you've got to do both f of g of x and g of f of x. It has to work for both. So I start with the first. So f of g of x means I take g of x and I plug it into the x on the f of x. So x plus 6 minus 6, the positive 6 and the negative 6 cancel out, and f of g of x equals x. That's what it's supposed to equal. Now flip it so that it's g of f of x. Take the f of x and plug it into the g. X minus 6 plus 6, these cancel and you get just x. Again, that's what you should get. If it says they are inverses of each other. If the question says, are they inverses? Now you're checking to see that they're both x's, and if they're both x, then it's a yes. If they're not both x's, it's a no. So those are the two different kinds of questions on this part, like a verifying and are they. Now B says f of x equals x squared minus 3, where x is greater than or equal to 0, and g of x equals x plus 3, square root of x plus 3, where x is greater than or equal to 3. So I'm actually I'm gonna take a picture of this. We're going to come back to this part, like ignore the restrictions for now. I'll come back and talk about that in a little bit. We're going to do the same thing first, which is f of g of x that we did before. Take this, plug it in here, and I get the square root of x plus 3 squared minus 3. The square root of x plus 3 squared is x plus 3 minus 3. These cancel, and I get just x. Again, the work is the proof here because we know that's what it should be. Okay, then I do g of f of x. I take this one and I plug it into here. So I get square root of x squared plus, x squared minus 3 plus 3. The negative 3 and the positive 3 cancels. And I end up with the square root of x squared, which is x. It's actually absolute value of x, but that's where those restrictions come into play, which we'll talk about in a little bit. So first part, it's telling you that it is an inverse. You're verifying it. The way you verify it is f of g of x and g of f of x, and both of them should just give you x. Questions so far?
Can you leave it there for a second?
Certainly. Okay, second type of question will be find the inverse. These are the steps. So we're going to take f of x and replace it with the letter y because those mean the same thing. Then we're going to switch the x and the y. So everywhere there was an x becomes a y. Everywhere there was a y becomes an x. We're going to solve for this new y so that y is on the side by itself. And then to show that this is the inverse, we're going to replace the y with f negative 1 of x. So my answer is going to be f negative 1 of x equals something. Now, you're not going to have to do this part on WebAssign, the f negative 1 of x, okay? But test and quiz, you're going to probably have to do that. I don't know how I'll format this one, but you're probably going to have to do that. So just keep in mind that that's part of the actual equation.
So what's the difference?
This is just going to give you f of x equals this, right? One equation, x plus 3, let's say. Find the inverse.
Oh.
So now you're creating the inverse, right? Okay. So the inverse of a function in general is just if I take whatever it is, whether it be a graph or an equation, whatever it is, and I change the x's and the y's, I switch them around, I'm creating the inverse. So with an equation, that's how we do it. We take the x, we replace it with the letter y. In a little bit, you'll see like if I had a function that I had graphed, I would find those coordinate points and switch the x's and the y's. That's what an inverse is.
Oh, okay.
All right, so here we go. Find the inverse function of f. So A says f of x equals 7 minus 3x. Step 1, change that f of x to a y. Step 2, switch the x's and the y. So the y becomes an x, the x becomes a y. Step 3, solve for that new y. So I have choices. I can subtract the 7, moving it to the left-hand side. And then I can divide both sides by negative 3. And I end up with y equals, I can do x minus 7 over negative 3. Or I can split those because sometimes I'm going to have to factor these. Graph these to negative 1/3 x plus 7/3. So I split that fraction into two parts, giving the 3 to both, right? So the negative 3 went with the x and the negative 3 went with the negative 7.
Is Chris Wesley?
Yes.
When we switch the x and y's, would like powers carry over or no? Just
Yeah.
change the-
No, like if it said x squared, it becomes y squared.
Okay.
Yeah. Good question, Sai. Okay, so then my answer gets formatted as f negative 1 of x equals, and again, WebAssign will either take this answer or it will take this answer. If you have to graph it, realize you're going to have to split it to graph it. If you're just giving it as an answer, I don't care which of these versions you give. Well, this should be f negative 1 of x equals, okay? But again, the f of x, I can't leave that because this is not f of x. I changed it. This is f negative 1 of x. So it's important to realize that those are not the same things. That's why we make it f negative 1. That one could be an equation like y equals mx plus b form, but they're not all going to be lines. Like the next one, right? You'll see it. So what changes, the steps don't change. What changes is what kind of equations you're building. So if I look at B, step 1, make that y. Step 2, switch the x and y. Step 3 is solve for this new y. So I want to get rid of the variables in the denominator. I'm going to multiply both the right and the left by y plus 2. These cancel, and I get x times y plus 2 equals 1. Then I have to get this y by itself. So you have two options here. I'll work them both out. What's the one next step you can take? Because there's two technically.
Divide the x.
I can divide both of these by y plus 2. Nope, that goes back to the other side. Just kidding. Both of these by x. So it cancels from here, and I get y plus 2 equals 1 over x. And then I would subtract the 2 from both sides, and I get y equals 1 over x minus 2. So f negative 1 of x equals 1 over x minus 2. That's one answer. That is correct. What's another step you could have done from this step?
Distribute the x.
I can distribute the x. So I get xy plus 2x equals 1. I would subtract the 2x. I would divide by x. And I would get f negative 1 of x equals 1 minus 2x over x. These are the same equation, just a different format. They're both right. If I was to graph it, I'd have to split it and simplify it, right? This is a reciprocal function shifted down 2 places. And the original was a reciprocal function shifted left 2 places. Questions on those? So finding, first, replace the f of x with a y. 2, switch the x and the y. 3, and this is the step that can vary, that like varies in length, solve for the new y. 4, make the y f negative 1 of x to show that this is the inverse. All right, how to graph them. So if I'm given an equation, I can obviously find the inverse the way we just did it. But if I'm given a graph or coordinate points and I want to find the inverse, I physically switch the x's with the y's. So if I had a point on my original f of x that was 2, 3, then the coordinate point on my f negative 1 of x becomes 3, 2. I switch the x's and the y's just like we did in the equation. Okay, so that was if if you're trying to move points, right? This is if you are trying to figure out if something is a function. So opposite of the vertical line test, right? Vertical line test tells you, is it a function? This is called a horizontal line test, which tells you, is it 1-to-1? And
Right.
if it's 1-to-1, you good?
Oh, we're gonna do it.
Okay. If it's 1-to-1,
All right, I'm gonna move you guys along. We're gonna get back.
then it has an inverse. So 1-to-1 has an inverse, not 1-to-1, you can't find the inverse, okay? So the simple test for is it 1-to-1 from a graph is the horizontal line test. If it fails the horizontal line test, it's not 1-to-1 and it doesn't have an inverse. If you look at the points, so think about the test we used for function, right? For a function, we said the x couldn't repeat with a different y. Switch the x and the y's now. For points, then the y, the x, and I think this is actually, let me change the wording on this because I think that's confusing. The y can't repeat. Holy cow. Repeat with a different x. So the flip of what we did for if it's a function, right? A function we said x can't repeat with a different y. Inverse we say y can't repeat with a different x. And then there's one more way to test, which is the equation, which we'll get to in a minute, okay? So, but in order for these to be 1-to-1 functions, they have to pass the function rules. Then they have to pass the 1-to-1. So 1-to-1 just means it has an inverse, okay? So it can't have an inverse if it's not 1-to-1. And that would be if the y repeats with a different x or if it fails the horizontal line test. So here's the easy part. Draw some horizontal lines, okay? First it says determine if it's a function. So what's the test for the function?
Vertical.
Good. So I have to do the vertical line test first. Then if it is a function, determine if it's 1-to-1. So what's the test for 1-to-1?
Horizontal.
Good, horizontal. And then if it is 1 to 1, actually graph the inverse, and we do that by switching the x and y's, which I'll show you in a minute. So let's start with A. Does this pass the vertical line test? No, and those are the ones you pray for because you're done. It's not even a function. If it's not a function, it can't have an inverse. Then you go to B. Does B pass the vertical line test?
Yes.
So this is a function. That gets you past the first one. Now, if it's a function, does it have an inverse? So is it 1 to 1, meaning does it pass the horizontal line test?
No.
Nope. So it's not 1 to 1, which means it does not have an inverse. So 2 steps, still not that bad. Then we go to C. Does it pass the vertical line test? It is a function. Does it pass the horizontal line test? Yes. It is 1 to 1. Now I have to find the actual graph of the inverse. So to do this, I don't have points. I'm just going to plot the points. How did I lock this? Hang on. I'm going to plot the points however I want, just making it consistent. So I'm going to say 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. As best I can, consistent spacing. And then I'm going to pick 2 points. So let's say I pick this point, and let's say I pick this point. Get the coordinates of them. So this one is -2, 0, and this is 0, 3. If that's my initial points, then the inverse switches the x and the y. So my f -1 of x coordinate points are going to be 0, -2, and 3, 0. So I plotted some points. I switched the x's and the y's. This is a line, so I really only need 2 points. And now I'm going to plot those points. 0, -2, and 3, 0. And then I'm going to draw my line through those points. So there's 2 checks at the beginning. Is it a function? If it's a yes. Is it 1 to 1? If that's a yes, then find the inverse.
Ms. Christweiser?
Yes.
Should these lines be parallel or no?
They actually will be symmetric over the y = x line. They don't necessarily have to be parallel.
Okay.
Question so far? Okay, now I'm given like an x and y chart. The A is domain and range. So think about it. Domain is your x, range is your y. If the graph, if the chart itself confuses you, then write it out in like coordinate points. So this first arrow says 1 hour goes with 80 miles. The second arrow says 2 hours goes with 80 miles. The third says 3 hours goes with 100 miles. Now remember, in order for it to be a function, the x can't repeat with a different y, and it's not happening, right? The x's don't repeat. So it is a function, but in order for it to be 1 to 1, the y can't repeat with a different x. The y, 80, is repeated here with different x values. So this is not 1 to 1. It does not have an inverse. Questions on that one? Okay, B says 1 goes with -2, 2 goes with -4, 1 goes with -3. What's wrong with this?
It's not a function.
It's not even a function. Which means it can't be 1-to-1. If it had said 1, -2, 2, -4, and 3, -3, the ones don't repeat, the x's don't repeat, that's a function, and the y's don't repeat. This would be both a function and a 1-to-1.
Ms. Kurzweiser?
Yes.
Will there ever be a time where set of coordinates are not a function but do like follow the rules of inverse, or no? You have to be a function.
They're called inverse functions, so by definition they have to be a function first.
Okay.
Does that make sense?
Yeah.
Yeah, okay. Questions on those? Okay, last test, which is the equation. Now think back to the test for functions dealing with equations, okay? To see if it's a function, the x is not what I'm looking at. It's the y. The y cannot be raised to an even power, and the y cannot be an absolute value. Those were the two things that made it not a function, which I thought was going to be like an easy gimme question on the test, and not everybody got it right. That's the test for function. Now, switch the x and the y's. What's the test for 1-to-1? Now we're looking at the x. The x cannot be raised to an even power, and the x can't be inside absolute value bars. Think about what kind of graphs would result from these. If it was raised to an even power, so what's an x squared?
That's the
A
even
parabola.
Parabola. Is that a function?
Yes.
Yes. Is it 1-to-1? No. How about absolute value of x? Is it a function?
Yes.
Yes. Is it 1-to-1?
No.
Good.
When you have to graph the inverse function, like how many points would we have to use?
It depends on the kind of graph it is. So if it's a line, 2 points is sufficient. I would say if it's a parabola, well, not a parabola. I would say if it's a square root, maybe 3 so you get your curve. So it just depends on the graph. A cubic function, 3 points. I would say if it's not a line, 3.
Right. Okay.
All right, so now I'm going to bring back in, remember I told you I took a screenshot before because we were going to talk about it again. I'm going to come back to this example. And now think about why we needed that restriction. Let me group this. Shrink you. Sorry, I talk to myself when I'm doing things like this. Okay. Look at f of x, the first one, right? F of x says x squared minus 3. That's a parabola shifted down 3 places. This, as it is, fails my horizontal line test, right? This cannot have a function, cannot have an inverse. But this little part says where x is greater than or equal to 0. So now we're really saying I only want this part of that graph. I would erase off the rest of it because this is like a piecewise. And that now passes my horizontal line test. So that's why you'll see those restrictions. Don't stress about finding the restriction. Just realize that's why they're there. So if I look at the second one, the original function, g of x, left 3, that's not a problem. Those all work, right? But there's a restriction this time because of my domain. If it's a square root, it's got to be greater than or equal to 0, which means x has to be greater than or equal to 3. So that, or negative 3. That's not restricting my graph. That's restricting my domain.
No, we don't have to look at that.
No, I'm not going to ask you to find it. Just realize that that's part of it, and that's why they're there. The only other thing would happen is if it said, like, is the function 1-to-1, and if I gave you just f of x equals x to the third minus 3, the answer's no. But if I give you f of x equals x to the squared minus 3, where x is greater than or equal to 0, that answer is yes. So pay attention to the restrictions, but you don't need to create them, if that makes sense. Everybody still okay? Yes? Riveting information, I know. The ceilings look very excited, I just have to tell you. Okay, last slide. Determine if the function has an inverse, and then a couple of them I'll actually find just to practice, okay? So super easy yes or no answers, okay? Again, it has to be a function and then have the inverse. So you're looking for 2 tests. In A, there's no y, right? The y is actually f of x, which means these are never going to be squared or an absolute value if they're in function notation. So the check is already done for the function part, because you're never going to see an f of x squared or an absolute value of f of x, which means the function test is already done. So now I'm just saying, does it have the inverse, which means, again, x can't be raised to an even power or an absolute value. That's when it's a no. So does A have an inverse?
Yes.
Yes. Does B have an inverse?
No.
No, because the x is raised to the even power. Does C have an inverse?
Yes.
Yes. Does D have an inverse?
No.
No. Easy stuff, right? Especially on WebAssign, where you get 3 chances to answer a question. If you get these wrong, shame. Shame, shame, shame. All right, so let me just look at C, one last one, okay? Let's talk about how we would find that inverse graph and equation. So this is a cubic function shifted down 2 places. Down 2, plot a point, shifted like this, right? So I would figure out what some of these coordinate points are. If I plugged in 1, 1 to the third minus 2, 1 minus 2 is negative 1. This is negative 1, 0. Nope, I plugged in, just kidding. Said one thing and wrote another. I plugged in 1 and got negative 1. So 1, negative 1 is here. Plug in like negative 1, and I'd get negative 1 to the third minus 2, negative 1 minus 2, which is negative 3. And I get negative 1, negative 3. And then this coordinate point here that we know, 0, negative 2. Now take those 3 points, 1, negative 1, negative 1, negative 3, 0, negative 2. Find the inverse, which means switch the x and y's. So this is the f of x points. And I would get negative 1, 1, negative 3, negative 1, negative 2, 0. And if I were to draw that, negative 1, 1, negative 3, negative 1, and negative 2, 0. And my graph would look like that. So it will be symmetric over the y equals x line or the y equals negative x if it's going the other way. If I fold it along there, it would be symmetric. But you're simply switching those points. The other way to find it, make the f of x y, switch the x and the y, solve for the new y, and change it back to the f negative 1 of x. Oops. Now that's a cube root, which looks like this. Shifted left 2 places, which is the same thing we just got, plotting points. Questions on inverses? You completed your first chapter. It took 4 weeks, but we did it. Okay, and again, this will get looped in with chapter 2, all the quadratics. Everybody's good?
Miss Chris Weiser?
Yep.
Could you go back to the slide where you were